Imagine a robot, not a giant clanking machine. Think smaller, much, much smaller. We are talking about tiny robots. Robots that can swim through water, robots that can fly through the air, some can even use tiny explosions to move. It sounds like science fiction, doesn't it? But it's real. Scientists are building them. These are marvels of engineering. They are incredibly small. Some are lighter than a paperclip. Imagine robots the size of an insect. They can go places humans cannot. They can perform tasks too delicate for us. This field is buzzing with innovation. It's a new frontier of technology. Welcome to the microverse of robotics. Consider the possibilities. What could such tiny machines achieve? They could explore unseen worlds. They could repair things from the inside. They could carry tiny messages or sensors. The universe of the small is vast, and these tiny robots are our explorers. Where do scientists get these ideas? They look to the ultimate engineer, nature. Think about it. Nature has been perfecting tiny machines for eons. Insects are a perfect example. A fly can hover, dart, and land upside down. Its wings beat hundreds of times a second. How does it achieve such aerial agility? Scientists study these natural flyers closely. They are reverse engineering nature's genius. Then there are creatures on the water. Water striders, for example. They dance on the surface of a pond. They don't sink. It's amazing. They use the water's surface tension. Their legs are specially adapted. Roboticists try to copy these tricks. They design tiny robots that can walk on water, or swim like tiny fish. Nature provides the best blueprints. This approach is called biomimicry. It means copying life. Nature has solved so many problems. Building tiny robots is incredibly hard. It's not just about shrinking big robots. New challenges appear at small scales. One major hurdle is surface tension. For us, water is just wet. But for a tiny insect-sized robot, water can be like thick, sticky syrup. It can trap a tiny machine. So how do they overcome this? It requires clever science and engineering. Scientists use special materials and ingenious power sources. One key technology is piezoelectric crystals. These are amazing materials. When you apply electricity to them, they bend, or they change their shape slightly. This tiny movement can power a robot's wings, or make its legs move. It allows for very precise control, creating tiny flapping wings that work. Another area of innovation is artificial muscles. These are materials that can contract or expand, just like real muscles, but tiny. Some are made from special polymers. Section 4. Micro machines, macro impact, real-world missions. So, these tiny robots are cool. But what can they actually do? The applications are vast and exciting. Think about search and rescue missions. After an earthquake or a building collapse, tiny flying robots could enter an area. They could search for survivors in tiny cracks, places where dogs or humans cannot go. They could carry tiny cameras or sensors, providing vital information to rescuers. Then there's the world of medicine. Imagine microscopic robots swimming in your bloodstream. This is called nanomedicine. These tiny bots could deliver drugs directly to cancer cells, for instance, leaving healthy cells unharmed. Or they could perform delicate surgeries, repairing tissues from the inside. No big incisions, faster recovery. Environmental monitoring is another big one. Swarms of tiny robots could be deployed. They could check water quality in rivers or monitor air pollution in cities. They could help us understand our planet better and protect its delicate ecosystems. Section 5. The exploding future, ethics and next-gen tiny tech. What does the future hold for these tiny robots? The journey is just beginning. Scientists predict they will become even smaller, even more capable, even more intelligent. Imagine robots the size of dust motes working together in massive swarms, performing complex tasks cooperatively. The technology is advancing rapidly. Materials are getting smarter, power sources tinier. The future of robotics is undeniably small. That exploding movement is fascinating. It's about controlled, powerful bursts. Dr. Chen's work with combustion-driven robots allows tiny robots to jump or launch, like a miniature grasshopper suddenly leaping. This could be vital for navigating rough terrain or for escaping difficult situations. It gives them a new dimension of mobility. It's a tiny power-up for these micro-machines. But with great power comes great responsibility. We must think about the ethical side. What if these tiny robots fall into the wrong hands? Swarms of nearly invisible machines, could they be used for surveillance or for harmful purposes? These are serious questions we need to ask. We need rules and guidelines to ensure this technology benefits humanity. Open discussion is crucial. The future is tiny, and it's arriving fast. These robots promise incredible breakthroughs in medicine, in exploration, in environmental care.